Good morning. We've got Mike, we've got sound. Good. How's everyone doing today? I'll be working still on my catching up on my exercises. Today I'll be working on proverb. So what does that do? What is the instructions? What are the instructions? Introduction, okay. For want of a horseshoe nail, a kingdom was lost, or so the saying goes. Given a list of inputs, generate the relevant proverb. For example, given the list nail, shoe, horse, rider, message, battle, kingdom, you will output the full text of the proverbial rhyme. For want of a nail, the shoe was lost. For want of a shoe, the horse was lost. For want of a horse, the rider was lost. For want of a rider, the message was lost. For want of a message, the battle was lost. For want of a battle, the kingdom was lost, and all for the want of a nail. Okay. Never heard that before. Note that the list of inputs may vary. Your solution should be able to handle a list of arbitrary length and content. No line of the output text should be a static, unchanging string. All should vary according to the input given. Okay. Download. All right, and we're going into TypeScript. Yes. What was the name of that thing again? Proverb. Nope. There we go. npm install. Ah, that's that metadata thing I thought I had seen. Track, exercise, ID, URL handle is requester. Interesting. All right. Add proverbs. Proverb. Exercise. All right. All right. Our first test case is a single consequence for expected. Okay, no, hold on. So we're passing in a variable length list of parameters. We need to make a toEqual method, and it's outputting nail shoe. For want of a nail, the shoe was lost. And all for the want of a nail. Okay, so basically, okay, I think the shoe was lost. For want of a shoe, the horse was lost. And all for the want of a nail. Interesting. All right, so let's start by making our class. So it's going to be proverb. It's going to be a default. Okay. Export default class proverb. Need a constructor that takes in a what are we going to call this? Search. Well, I'm going to call it terms. How's that? Terms Um, string array, and I think I need the spread thing or deconstruct, whatever that's called. Anyways, I think that should work. Okay. Now I need a. Wonder if I can do keep open from here. Reveal and explore. Nope. Okay. I need a to equal, right? To equal. Oh, wait a minute. No, 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 no. I didn't see that there wasn't a new keyword. It's actually expecting a function. Okay, cool. So export function proverb. Same thing now. So terms string array. We're going to be returning a string. Oh no, wait. Hold on. Right. Yeah, that's how it works. To equal is just, boy, it's a little too early in the morning for me. Okay. So yeah, we're returning a string. Cool. Now from what I understand, it's like my first thought is just like hard code the whole proverb and basically search for these terms. But I think that goes against the instructions, right? Note that the list of inputs may vary. Your solution should be able to handle lists of arbitrary length and content. That's cool. No line of the output text should be a static, unchanging string. All should vary according to the input. No line of the output text should be static. So, so I think from what I understand here, my idea is not right. Now, there's one thing I want to see. Oh, okay. For want of a key, the value was lost. And all for the want of a key. So there's always an all for the want of a something, and that something is always the first input, right? So here it should be nail again, and all for the want of a nail, right? So for want of a nail, the shoe was lost. For want of a shoe, the horse was lost. For okay, so and this here would be that's interesting. Proverb is the same each time. I don't know what implementation would make it so that it's different, but that's kind of interesting. All right, I don't think it's that complicated. I can just do, okay, and it ends with a period and then a new line. So let's just grab this. Actually, let's grab all of that. I'm just gonna put that here for now. All right. So we have so we could probably take our terms. map that. No, that doesn't work because we need two terms. Two of our terms in. Well, I mean, I could, but it's getting kind of ugly if I do it that way. Let's just for my, okay, let's see. Yeah, for sure I need to iterate through that terms array. That seems, I think that should be the driver here. So there's two things we need to do here. Okay, so this is gonna be proverb. No, let's make it a let. I'm just gonna let proverb equals an empty string. Proverb. Okay. And then we're gonna do for. Yeah, let's just use a good old. Oh, I need the index anyway, so. Length. Yep, and I plus. Simple as that, I think. And then I can just do proverb plus equals, and then just put that in here. We're going to be using this. So for want of a, this will be terms I, the terms I plus, no, I don't want to do it that way. Just I plus 1 was lost. Cool. Now, the thing is, when I get to the end, so if, oh, so actually, what am I doing? So proverb length minus 1. Okay. And then once I'm done with that, I just tack on proverb plus equal and all for the want of a something. Which will be our very first term. Like that. And I think that's pretty much it. Unless I misunderstood the instructions. Let's run this. I'm not returning it, of course. Now what? Proverb. Because I'm not exporting a default. Right? Yeah. Okay. And we're failing, so seems to be the problem here. Expected value to equal for want of a nail, the shoe is lost, and all for the want of a nail, and I only received and all for the want of a nail. Cool. Cool, 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 cool. Why though? Hmm. Proverb plus equal for want of a nail. Interesting. That's like it's not. Am I doing this right? Yeah, plus equal should do it. Let's say proverb. Pass in whatever, right? Dog. Then food. And all for the want of a dog. So okay, but why isn't it? Ah, okay. There's something wrong with my condition here. If I is smaller than proverb dot length minus 1. So okay, I guess that doesn't make sense because no, we're still okay. Yeah, stupid me. Stupid me. Terms dot length. There you go. For one of a dog, the food was lost, and all for the one of a dog. There we go. That is what. Ay, ay, ay. Okay, so got a good feeling about my solution. I can just open all of this up and see what happens. Relatively simple thing, yeah. If, like, I don't know if I have understood the instructions properly. So no line of the output text should be a static. So I think I'm good with that, right? The static unchanging string. All should vary according to the input given, which is what I'm doing, right? So I think that's it. That was a simple one. Kind of surprised that they have it at that level. After it's on the same level or even after stuff like variable length quantity that gets you to do like binary math and stuff. Hey, Lumi. All right, let's take a look at this. Oh, that didn't work. That's weird. What? Partition. I don't get it, man. Like, my solution is like 5 lines. How did you end up having to do something that's got 40? And I'll read through this off screen. Off stream. Well, yeah, I'm sure. I could also solve it in, in BrainFuck. But I mean, at some point, don't you want like people to be able to read your code? I'm probably just too dumb. All right, so I'm good with that. Let's just submit that. Window and partition functions are standard functions in FP languages. Okay, so you're basically implementing what would come with like the language in other languages. Cool. What was I doing? Oh yeah, let's just go commit this. Right, underscore Ramda. Okay, what was I doing? Oh yeah. Add solution. Solution to proverb. Got dyslexia today. Okay, just push that up, and then I'm good to submit that. Exorcism. Submit. Proverb.ts. I did take a look at the ISBN thing I was working on the other day. The one that you the gist that you shared. I did take a look. And the other one too. You also shared your solution to what was the other one I was working on? Matrix. Matrix. Yeah. Okie dokie. So that's good. Oh, let's just make sure that that worked. Proverb. Okay, good. Move on to the next one. Hey, Joe. Dropping by to see what you are up to. Can't stay long, no problem. As long as you can deal with the fact that I'm using something else than C#, you'll be fine. I'm working on exorcism.io exercises in TypeScript. Recite the nursery rhyme. This is the house that Jack built. I don't even know that one. The process of placing a phrase of clause within another phrase of clause is called embedding. It is through the process of recursion and embedding that we are able to take a finite number of forms, words and phrases, and construct an infinite number of expressions. Furthermore, embedding also allows us to construct an infinitely long structure in theory anyway. Papier? What the heck is that? Papier. Sounds like pap smear. Oh, okay. It's like, okay. It's like a syntax tree kind of thing here. Noun phrase. Or, yeah, papyrus. Oh, so I guess it would be pronounced papyr? Papyr? I don't know. I prefer papier. In French, papier means not bad. All right. The nursery rhyme reads as follows. This is the house that Jack built. This is the malt that lay in the house that Jack built. This is the rat that ate the malt. that lay in the house that Jack built. This is the cat that killed the rat that ate the malt that lay in the house that Jack built. That's a nursery rhyme? Damn. What do they teach those kids? This is the dog that worried the cat that killed the rat that ate the malt that lay in the house that Jack built. This is the cow with the crumpled horn. Okay, I'm not going to read the entire thing. Kill the cat that ate the malt that laid the house and Jack built. Okay, I wonder if there's like a specific melody to this thing. A lot of nursery rhymes are more... Right, why is that? Like, not just nursery rhymes, but also fairy tales, right? Like kids' stories. When you look at the original from like the, whatever, 15, 16, 1700s, it's like crazy stuff, like people eating children and... Yeah, they exist to keep kids in line. Yeah, maybe. Okay, so what's the... Okay, let's download this and probably the test cases will tell us a little bit more. Paste that in. Cool. What was it called? It was called house. Just house. Okay. House. And install. npm install. So Joe, do you work with JavaScript or TypeScript at all? Or is it really just pretty much purely C# at work? All right, so that's done. I'm just going to commit that. Add house exercise. Okay. I do a little jQuery stuff with my web apps. Cool. So, do you ever end up using NPM, or most of the time you just link? Oh, you did an Angular app once. Cool. I'm working in Blazor a little bit with Kramer right now, and I'm finding Blazor very similar to Angular so far from what I can see, except it's in C#, so it's pretty cool. Right. You've played with the whole NPM ecosystem. All right, so house. House. All right, man. See you, Joe. House test. Yeah, oh yeah, true. See you tomorrow. Verse 1, the house that Jack built. House.verse1 to equal lyrics. House.verse2 to equal lyrics. Right. Okay. And of course, we don't want to have that as statics. So the idea is that we're using recursion, and the process of placing a phrase of clause within another phrase of clause is called embedding. Uh-huh. So this never changes. That lay in the house that Jack built, that ate the malt. Okay, but the first time you introduce a new one, it's this is. May end up having to look at this papier thing. Although this seems a lot more complicated than Hypertext Books, Department of English, College of DuPage. I swear this website is from 1999. Started in 95. Been updating it though. Last one in 2017, but this here, this is old looking internet stuff. Move notes. Ooh, look at that. Drag and drop. Okay, cool. Yeah, I'm not going to read that right now. Let's try to figure this out. Process of recursion and embedding. That we are able to take a finite number of forms, words and phrases, and construct an infinite number of expressions. Furthermore, embedding also allows us to construct an infinitely long structure, in theory, anyways. Okay, anyways. So we're dealing with a static class, it would seem. Yep. Export. Default class house. I don't even need a constructor from what I can see. No, right? All I need is a verse that takes a number. Let's see here. Is there anything else we need to implement? Oh, verses. That's interesting. Start verse and end verse. Well, okay, let's worry about verses first. Yeah, but it's going to bug me. It's not going to compile if I don't at least make a verses one. So verse and verses, and verses takes in two numbers. Yeah, cool. So verse takes in verse number of type number, spews out a string. Okay. And then verse, oh, it's static. Static. And static verses takes in starting a verse, number. Probably just call this verse, I guess. And ending, let's use the same. Start verse, end verse. Okay, so start verse, end verse, type number, string, do. Now, how do I solve this? How do I solve this? Now, the thing is that we're starting, so first one, this is the rat. This is the mouth, so it always starts by this is. Oh, this is going to be a bit more complicated. Huh. What kind of algorithm this is so if I look at the pattern here, the first one always starts with this is. Uh-huh. So let's copy, let's get the last one. The last one will have everything we need. Okay. So no matter what verse we're getting, it always starts by this is. Right? So if we're looking at our first test case, which is verse 1, uh, the interesting thing here, I'm thinking of recursion, but oh, and here's an interesting thought. So verse 1 has one line, verse 2 has two lines, verse 3 has three lines, verse 4 has four lines. Okay. So now the thing that changes, so we've got names, or the rooster that crowed in the morn, the priest all shaven and shorn, the man all tattered and torn. But we also have like a verb here. They do something different. So that and the are always there. The verb, the action changes, and the thing changes. And our first sentence is different and starts with this is, and then the thing. This is the, and then the thing. So we obviously need to store, we need a map of action and thing. That seems pretty, I don't see any other way to go about that. Needs some kind of a map. Now it would make sense to map this to, let's see, a map or an array, or how do I pull from that map? Uh-huh. Well, I could make it an array of tuples, simply something like, what would I call this? dictionary, I guess, would be something like this. Dict would be an array, and then I could have, oh, now what's interesting is what order should I do this? Probably this order. House. Hold on, how does it start? This is the house that Jack built, right? This is the horse and the hound and the horn. Wait a minute. This is the farmer sowing his corn, right? So house and the hound and the horn. Oh, this is, that belonged to the farmer sowing his corn. Right. Okay, and it starts off with this is the house that Jack built. So the house that Jack built is okay. So house that Jack built would be the object, if you will, and the associated action before that is lay, I think. What am I doing? Okay, lay. Right. Huh. Would that make sense? This would be the first one. And then we would have 8. The malt. No, not just malt. And then we'd have killed. And then the rat. So rat. And then we'd have worried. The cat. Not that. Forget about that. Just cat. Then tossed. Dog. Then milked. Cow with the crumpled horn. Then kissed. The maiden, all forlorn. And married Men, all tattered and torn, woke. Even old-timey nursery rhymes people were woke. Priest, all shaven and shorn, and kept a rooster that crowed in the morn, belonged to, farmer sowing his corn. Finally, nothing here. And then horse, horse, and the hound, and the horn. Right. Now what do I do with that? That's a question. For the first verse, so if, let's just do if verse is equal 1, just for now anyways. Definitely going to change that later, but I just need to return put that in front of our function. And then I need to basically return hold on, this, okay, this is, right? This is, and then I can just pass in the first verse is, this is the house that Jack built. So this is, then I'd go dict, take 0. Well, hard coding this here until I figure out the algorithm, but and I'm looking at the object, so the object is index 1. Now I need to add probably a period, right? All right, so the last, all of those have, okay, a new line, and then the last one has just a period at the end. So if verse equals 1, then return this is blah, blah, blah. But no, that wouldn't be the right way to do this. I would want to have some sort of let house equal empty string for now. Then I could do using recursion, eh? Oh, hold on. Let's see. So let's say we're getting Okay. Okay. Let's think about this here. Let's keep it simple. Try to figure out the pattern here. Let's just get the first 3 verses. Which would be these here. This is the house that Jack built. This is the malt that lay in the house that Jack built. This is the rat that ate the malt that lay in the house that Jack built. So if I am to use recursion here, my thinking is that we're calling verse with the original number we're looking for. So we're looking for verse 3. Verse 3 would be this one here. How would we use recursion? We would obviously decrement, when we're calling verse again, we decrement the verse. So verse 3, we'd start off by right. How would we go about this? We would need to somehow accumulate so our ending condition is obviously that verse is equal to 0, and then when verse is equal to 0, you just return what? You just return some string that you've been accumulating, right? So you need to accumulate it somewhere. But verse only takes in a number. If I change that, is that gonna screw up? What if I make it optional, for instance, and just go house, and then just start it off with an empty string. If I do that, is that going to complain? No. Cool. Otherwise, I could just make another function and then call that. But let's try to do that in here for now. So verse. Then I'd return house, right? Okay, cool. Now, otherwise, if we're not at verse 0, we're starting off at verse 3. What do? I call verse, maybe, right? House.verse. I pass in verse -1. And then I pass in, well, house becomes something else, right? I need to take house and do something with it. So house equals that. So no, house plus equals, or actually I need to prepend. So a house is equal to whatever, 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 plus house. So then it would be that. That then my object, so it'd be something like dict which, you know, it really isn't, but what should I call this? I don't know, syntax? Maybe. Syntax. Kind of. I don't know. Syntax. Now how do I get the right one if I'm at 3? Right, so this verse says 3. And the first thing I should be putting logically is unless no, that doesn't work. I don't really see the point of doing this recursively. I could do this with a for loop. More easily, right? I don't know. This is a hard one. This is definitely a hard one. Okay. So if I do all right, well, let's keep going with recursion and see what I come up with. All right. So actually, let's first do if verse is equal to 0, then what I need to do is, not 0, sorry. First is equal to 1. Yeah, well, how do I accumulate the, no, I don't know, I'm just not getting it with the recursion here. Let's just try to implement this simply using a for loop first, and it might come to me. So for let I equals, we're going to say 0 for now. I don't know if that makes sense. As long as I is smaller than verse, actually, -1, okay. I++. All right. So what are we doing? When we're at index 0, we need to, okay, we'll have a let house equals an empty string. And then, okay, so if I is 0, we're starting building our string. What I want to do is, how do I know which one's the first one? Well, if we want verse 3, rat is the first one. And rat happens to be the third index. So how about we start everything at 1 here? Would this work instead? Nope. It would not. But it doesn't matter. Okay, so how would I get that? I would get that by saying syntax. We're looking at the third one. So it would always be I. Well, it always starts at 0, so really I can just hard code it here. So syntax I verse, I guess, -1. First -1. Simple as that. And that gives us, here, so let's start with, okay, so let's do a house plus equals and it's always this is. So let's do that. Oops. So this is what? This is something. Syntax, first -1. And then I'm looking for index 1 of that thing. This here would probably be enough to pass the first test case. I'm curious, let's see. Right, need to implement something here, so start verse, end verse, return string. There we go. Just so that it compiles. Expected value to equal, this is a house that Jack built. Oh, is it expecting an array? It is expecting an array. Crap. Screwed that one up, didn't I? An array of strings. So that's actually, it probably makes it a little easier for me then. So house is going to be this. Expecting a string array. So then all I need to do is basically push house dot push okay, forgot my period here. Okay. What seems to be identifier house is never reassigned to use const. Right, since it's an array now. Okay. I is smaller than verse minus 1. Keep going as long as I is smaller than verse minus 1. That should work. I'm returning an empty array. All right, time for Quokka. And we're dealing with a class house with a static of verse. And I'm saying give me the first one. And okay, so my condition is not, I'm starting at 0. I is smaller than verse. Why did I have -1? I don't know. But now this should work. Right? Yeah, I think so. Let's give it a shot with the test case. What? This is a the. I'm missing a the. Okay. This is a the. Let's try that again. All right, cool. Now, if I'm looking to the next one, which obviously right now won't pass, don't even need to try it, I know that. Verse 2 is what we're trying. So we're trying verse 2. Let's just put that in there right away. This is the malt. So we've got the right first verse, right? But now as we go around for a second, okay, so we would want to have an else here. So if it's not, actually I need 3 different ones because the last, oh crap. Nope. Just figured something out, right? Because you don't want that period here necessarily. So house plus equals. Let's make that simple. Just shove a period at the end. Oh, right. We're not dealing with a string anymore. So house. Oh, that bites. Okay, that would have been simpler. No biggie. I can just all right, I just need a local variable here. So let line, I guess we're going to call it. Would that be it's a line in the, sure. Let line equal this. And then we're going to do line plus equals this thing here. Then else we do something else. And then at the very end, we do house dot push. And we push our line. Actually, yeah. But we also need a, so else if here is going to be something. And then else is going to be the last. Actually, hold on. Let's not go too fast here. What am I doing? What I want is something that just adds a period to the last line of my verse. So I need something that says, so that doesn't really need to be an else if. I just need an if here. If I is equal to verse -1, right? If I is equal to verse -1, then just go ahead and add a period. Good. Then once we get to this, you can push it real good. Okay. So this deals with the first line, which is the only one that has a this is the. All the other ones will have um, what's the format here? That did something. Lay in. Did I have that properly? So it's lay in. Gotta get this right. Lay in, 8 killed. Blah, 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 blah. So that was a tricky one here. Okay. So now, all I need to do here is that. And then, so this is probably not at all the way they want me to solve this, but I just can't make sense of any other way right now. That action object. So that syntax verse -1 object and the and here we're adding syntax verse -1. So I can probably store that somewhere else, but this just want to make sure. This is the malt that ate the malt. No. No, 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 no. Okay, yeah, because I need to use I here. So verse minus I. This is the malt that ate the malt. Nope, that's the same thing. Does make sense. So what are we doing here? If we're doing verse 2, it should be this is the malt. So we're getting that right. And then it should be that late in the house that Jack built, which is the first one. Right? So let's think about this. We're getting verse -1, so cool. Now we need to, as we go forward, reduce by however -1 minus I. This is the malt that lay in the house that Jack built. Oh yeah. I think I've got it. I think I've got it. So let's run a test. Cool. Verse 3. Verse 3. This is the rat that ate the malt that lay in the house that Jack built. Alright, I think we got it. Let's run the test on this. Okay, cool. So, right on. I can pretty much open this up. Verse 5, verse 6, verse 7, verse 8, verse 9, verse 10, verse 11, verse 12. Let's do that. See if we pass all of those. Oh, that belonged. I belonged. All right, let's do that again. And we're good. Now, I wonder what, like, if I wanted to use recursion instead. I don't see how much more simple it would be, or cleaner, if I used recursion on this. I don't know. So, okay, a little bit of cleanup here. I've got verse -1, a bunch of places. I could probably store that in a local variable. What does that represent? Verse -1. Just the index of actually, in essence here, we are also doing verse -1 minus I. So let's call this just index, I guess. Well, let's call it in syntax index. No, let's call it and this isn't really an index. We're just iterating, so I'm going to change that to probably. Okay, so this is going to become index, and this is what this is going to do. Okay. Index. Index and index. Let's just run the tests to make sure this works. Yeah. Now, let's change this to be, instead of I, what would this be? It's an offset, really. That's what it is. That's all we're using it for, as an offset. Kind of. First minus 1 minus offset. Now, why do we need first minus 1 here? That's kind of an offset into itself as well, right? What is this? What is the significance of the minus 1? I guess another way to do it would have been to start at the, because if what we're doing is just going down, this might have been cleaner. Might have been a cleaner way to do it. This might have been a cleaner. Okay, let's try this. Let's get back to what we had here. Actually, let's get all the way back to what we had. We might be able to do this differently. So I could be equal to verse as long as I is bigger or equal to 0. Actually, let I be equal to, whoa, what's going on? Oh, I know what's going on. Quokka's flipping out. All right. Verse minus 1. As long as I is bigger than 0, then we do I minus minus. We reduce. So first, we gotta do it the other way around. So instead of I is equal to 0, it's I is equal to verse minus 1. So that's cool. We do that. Then for every other case, oh, actually this would change as well, wouldn't it? Would it? Hold on. Let's see what we get here if we do that. This is the house that Jack built. Okay, so we're good. And if I get 2, it should be, this is the malt. Cool. That ain't the malt. We're going to fix that in a second. That, and now here all we really need to do is take I think. Let's take a look. Yep, this is a malt. That lay in the house that Jack built, so this is cleaner. I like it. I like it. And now we're getting closer maybe to a recursive way of doing this, because I'm starting off with verse as number, say, 3. Okay, let's do that. That lay in the house that Jack built. That ate the mold. Rat. Yeah, so that's good. I'm pretty sure I'm still passing my tests here. Oh, what? Okay, hold on. This is a horse that belonged to the farmer that kept the rooster and crowned the morn that woke the priest that ate the malt that lay in the house that Jack built. What's the difference? Oh, didn't fix this. If I is equal to the last one would be if I is equal to 0. Let's run this. Yeah. So now if I wanted to do this recursively, what would it look like? I'd keep the verse here. I'd need to keep the house in there. Let's try this just for kicks. Because they really seem to want us to do it recursively for some reason. So let's try to give the people what they want. Just going to comment that out for now. What the heck? Okay, good. So, all right, if I'm doing this recursively, I need to track my house from one call to the next, right? So I need like a house equals an empty array. I should probably type it though. It's a string array. Okay. Now, what are we doing in that for loop? We are so that would be still happening. So let line equals this. All of this would still be happening, I think. Except that now it would be if verse is equal to verse minus 1. Actually, no, because now we're doing let I equal verse minus 1. So if this is the first one, basically, so if verse, how do we know? How do we know that it's the first one? How do we know that it's the first thing that we do? Well, house would be empty. So if house dot length, we know that it's our first line. Cool. Then we do line plus equal. This is the syntax, blah, blah, blah. Verse minus 1. Yes. Else, if it's not the first one, we do this here, except that now we need I was equal to verse minus 1. So verse minus 1. Okay. Verse minus 1. And then if verse minus 1 is equal to 0, line plus plus equals, I put my thing in here, Okay, so when do I stop and output house? When I actually get to if verse is equal to 0. That's my ending condition. Then I just return house. I really don't see why this is better than, actually makes for a more complicated, well, maybe, I don't know, we'll see. All right. And then I just return actually, I don't return it, do I? Yeah, I do. Return this dot, oh, it's static, so house dot verse. Let's pass in the verse -1 because we're decrementing, and we need to push here. We need to push. I can do that here. So house. No, actually, need to do that here because push returns doesn't return the array. So push the line, and then let's pass that on here. This is the rat that ate the malt that lay in the house that Jack built. So that works. It works recursively, but don't really see a point of doing it this way. We've got this thing is 39, so 17 lines long. It is not shorter. It's not really easier to understand. So there's probably another way to do this recursively that is like more, I don't know, that's just better, but this one here is, we had 17 lines, right? For this one has 17 to 36. It's about the same. I'm just going to keep this one. All right, moving on to verses. Stop the Quokka. Now verses also expects an array of strings. Ah, crap, we need to add an empty string. Well, that's not a big deal. Okay. So we're expecting an array of strings. And here we're doing so we're basically just start verse, end verse. So let's iterate through yeah, I is equal to start verse, go until you hit end verse. Actually, we want end verse inclusively. Probably. Yeah, we do. And then I plus plus. So then I could just do, okay, so this will be const verses. This should just be verse, actually. Verse. Oh, that's interesting. Oh, crap. Yeah, okay. So let's change that to verse number. There we go. Ah, crap. Okay. So first we change this to verse number. Then we change this to verse. Okay. Now, this will be verses, verses. It's equal to an empty array. So as we're doing this, we're just going to be calling house dot verse with our verse number. That's going to return, oh, yeah, that's going to return an array. But we don't want it to be in an array format, do we? Well, we kind of do, but okay, let's just do that for now, and we'll figure out a way to flatten all this stuff, probably just using flat that we now have in JavaScript. Yay. So simple as that, and we also want to push after that just an empty string. And then we're in business. And yeah, let's just return that for now. Verses, see what that looks like. From verses 1 to 3, let's say. Let's run this. Type string or string array is not assignable with type string. Oh, all right. Cry me a river. So let's do verses dot flat. Now it's saying, oh, it doesn't exist. Oh yeah, it does. Let me show you that it does. Tsconfig, yeah. ES next. Let's add lib. Don't even know if I need to do that, but I'm doing it. Okay. Expected 8 comma. There's your comma. So that's done. Also need to install. Actually, need to change this and make sure we've got the latest version of TypeScript. Or more recent anyways. And now, everything should be kosher. Yay. This is the house that Jack built. This is the malt that lay in the house that Jack built. This is the rat that ate the malt that lay in the house that Jack built. Perfect. Oh, maybe this could be done recursively. Maybe this could be done recursively. Ah. Why? I mean, this works perfectly fine. It's not like it's complicated. So let's open this up for tests. Multiple verses. Full rhyme. That's it. We've got all of them open. Yep. npm test. Oh, what seems to be the problem? They both failed because, yeah, of course. I'm adding this even for the last one. Fine. All right. If, let's say if I is equal to, or is not equal, how's that, is not equal to inverse, then just go ahead and push an empty string in there, if you don't mind. Thank you. There we go. Okay. Zayam is satisfied with this. I do solve the problem. It's not too complicated of a this though. This isn't exactly easy to read. So, could I do better? Could I do better? I certainly could. Like, I could say, I equals verse number minus 1. Mm-hmm. It's true that it's not exactly easy to read. I could probably do better with this here at least. So this essentially means if this is the first line, extract to method, constant, or function in module scope. So should I make this a method in the class? Should I make it a function in module scope? No. A constant in enclosing scope. Maybe. What would that look like? If is first line. I don't like it that it's there. But I don't see it making much sense to have a, well, let's see what house dot is first line. What would that look like? I and verse number. This is just confusing. So it's relatively simple logic too, so. Mm-hmm. Is first line is equal to I, first number minus 1. Sure, why not? And then if I is equal to 0, we can make this is the last line. That's like basically making a comment. All right, so if is first line. You do this. Otherwise, if it's not the first line, you do that. Now, if it's the last line, you add that to the line, then you verse dot push line, and you return the verse. Okay, so it's a little bit more readable. You understand a little bit more. Like, you don't need to care that much about the index and the offset and all that stuff now that I've got this, right? So I added 2 lines, but made it a bit more readable. In here, I mean, it's really not that hard. All right, I think that's good enough for me. Whoops. Not what I wanted to do. The heck? Come on. Control plus dot. I should get used to using that. So if I do that, well, look at that. Ooh. Fix all auto fixable TSLib features. Yay. Okay. Let's just run the test again. Oh, cool. So did you solve this recursively? So my whole thing is about 50 lines of code. Is yours like 1,000? Because you implemented like 60 functions that are normally built into Haskell or something. Oh, nice. Wow. Yeah. I'm definitely going to take a look at that. Definitely going to take a look at that. Actually, before I forget, did I copy your... I don't think I did. Let me do that right now. Can I? Good. I'll put that here and this one right there. Perfect. Cool. Okay. Did you sign up for exorcism.io? Are you doing these like on the site itself, or you're really just doing it in the gist? Because you might as well. Might as well do it in, on exorcism.io itself. If you're solving these, right? Oh, you should. You should. You might as well. It's a lot of fun. Have you ever, like I haven't in a few weeks played on codinggame.com, but that's another site that I really like for coding challenges and puzzles and games and stuff. Have you ever Heard about it? Have you seen me do some coding on that? I don't know how long you've been following me. I can't remember. It's been a little while, but I haven't been on Coding Game for about at least 3 to 4 weeks, I would say. Coding Game is really cool because they have puzzles, but they also have like I forget what they call them, but it's like challenges where you build a bot for a game, and they've got like a bunch of different games, right? So you build a bot to play the game, and then they take your code, they take your bot and pit it against other people's bot, and it's like a league, and there's rankings and stuff, and it's really cool. All right, so I think that's it for me. It is 10:52. I'm definitely not going to have time to do another one before 11. That's for sure. So I think I'm going to call it quits for this one. And I'll take a look at Lumi's solution. Tomorrow, if you want to join Lumi, I'm going to be streaming in the afternoon, my afternoon. So whatever that is for you, I think you're in Germany. But I think at around 1:30 p.m. Eastern Time is when I should be on. So feel free to join me if you're available. If not, I might see you next week. Hope to see you next week. All right. Take care. Bye-bye.